Hey there, Secure Code Warriors. I hope you're enjoying your Devlympics 2021. My name is Sal, I come from Sonatype, and today we're going to talk about why mean time to update is probably the best metric you've never heard of. To do that, we're going to understand why there's a new wave of cybersecurity attacks, how these vulnerabilities are entering your supply chains, where versioning and open source herd behavior can affect best practices, and why MTTU provides not only a good way to improve your architecture, but improve the global supply chain that we all depend upon. At Sonatype, we're really interested in what this global supply chain looks like, and we're uniquely qualified to understand it because we've been hosting the Maven Central Repository for over a decade. You may know this better now as the Apache Maven Central Repository. Understanding what it looks like when an open source project is contributed to this global community and how teams and individual developers then take those to incorporate them into their software. And right now, over 90% of modern enterprise application components come from open source. So this is really the most standard way of working in software delivery these days, and it's absolutely accelerating. So the increase in downloads that we've seen over the major software ecosystems has been anywhere from 50 to over 90% in the last year alone. And sometimes that means that those downloads are of projects which are under-maintained. This is a really great example of what it looks like to build a modern digital infrastructure where some components of it may be vulnerable to cybersecurity attacks. And there are a minority of agents in the open source community that are interested in exploiting those vulnerabilities. We have seen an over 650% year-over-year increase from the traditional traditional cybersecurity attacks to really the next generation that target open source. And when they are targeting open source components, they're not just going after the older or unmaintained projects, they're actually targeting, on average, those that have the highest density of downloads, so the most likely to be utilized by a broad community of developers. So what do these attacks really look like? We're going to cover the top 3 that we saw in 2021. So the first I want to go over here is typo squatting. This is pretty easy to understand. This is going and creating a new open source project, quote unquote, using something that is just slightly offset from the real project that people are trying to incorporate. Matplotlib had a really great exploitation and example of this in 2021 when they had variations on Matplotlib, sometimes with 2 P's or 2 L's, that instead of downloading that library, would instead install a crypto mining malware directly onto your system. This is another example of typo squatting where they were attacking a Docker image. So this is a good example to show that this is something that exists at all layers of your architecture. Another really interesting version of these next generation attacks is the dependency or namespace confusion. So this is when a bad actor publishes a malicious package using the exact same name as another one, but using a newer semantic version. So these are really things that can catch you if you're using something like a Dependabot to update. A really excellent example of this occurred in just February of 2021. We were able to capture this in part because these were exploitations produced by a white hat hacker, meaning that they were doing this intentionally to explore these and make these available to those that were vulnerable from them. However, in disclosing these, they also made a case for bad actors to come in, and after disclosing a few of these, they found that over 10,000 additional copycats came in to exploit some of the dependency confusions that they had made in NPM and other ecosystems. The last one we're going to talk about in this new generation of attacks is malicious code injections. So these are very interesting. They're also incredibly hard to locate when you have them on an open source project. So these are ways of going in and really capturing the entire real open source project, either by stealing credentials, releasing new versions, contributing pull requests which introduce malicious code, or tampering directly with the open source tools. Typically, no one knows that that kind of malware is there except the person who planted it, and so it can take a really long time to find these. One of the biggest examples that you probably saw in the news of this was in December of 2020 when SolarWinds had one of these malicious code injections, which went from their code base into the National Security Agency, the Department of Treasury, and NASA, as well as 18,000 other customers before it was found. So how do we tend to deal with these vulnerabilities and attacks as developers? In part, we do this by making sure that we regularly update our components to newer versions that are less vulnerable. In this, you can see some of the migrations decisions that are made by proactive teams, meaning that you want to move to a version which is very well supported, that many others are going to, and that has been proved to be pretty resilient against novel attacks. To do this, typically there's a combination of decision making that developers make. There are these initial architectural decisions, really what component, what package, what project do we want to rely on, but also what are the versions within that we need, not only of that component, but of some of the dependencies within it. Now you may think that you have some of the best practices in place for this, but when reviewing over 100,000 applications with over 4 million component migrations, we actually found that on average, almost 70% of the developer decision making was suboptimal. So no, they absolutely weren't going out and choosing the worst possible version, but there typically was at least one version that was more resilient and less susceptible to these vulnerabilities than the one that they chose, meaning that they're going to have to go back and refactor that at a later time. And as of 2021, only 31% of those developers were making, on average, an optimal decision for that version chosen. Now, typically, when we're making that decision about choosing the right project and the right version, we can lean on some metrics that already exist. Libraries.io has a really good metric from SourceRank where they rate the quality of a project based on the project documentation, the maturity, and the community, all into a single score between sort of 0 and 30, 30 being the best score. OpenSSF also has a criticality score where they look at factors like community, usage, and activity. In this, they're not just looking at whether or not it's a healthy project, but they're also trying to see, is it really depended upon inside of that ecosystem? How critical is that to that open source ecosystem? And today, I want to propose that we should start utilizing, in tandem with these, this mean time to update. So this is understanding project quality based on how quickly that project moves to update its dependencies. A lower score, a lower MTTU, means that it's a better outcome. This means it's a project that is updating its components very quickly, making sure that they are less vulnerable in real time. And one that has a very high MTTU, that means that they spend a lot of time between releasing a version and releasing a less vulnerable of that version of that component. So when we're calculating MTTU for a given component, we're going to look at all versions of the dependencies within it, calculate how much time it takes between when that version is released and when the overarching component is updated with that dependency update inside of it. Then we compute on average what that looks like for all of the dependencies in that component. And really, what this gives us is not a direct measure of the speed at which projects fix disclosed vulnerabilities, but it really strongly correlates to the mean time to remediation, which is the time required to update dependencies that have published vulnerabilities. So if you are paying attention to this as a metric that you can record when you're making architectural decisions, it's going to have a real impact on the human hours that you spend refactoring your own architecture later on. And one note on this is that when you evaluate open source through this lens, you can see something really interesting. That's that this mean time to update has been accelerating almost continuously over the last decade. So in 2011, it took over a year on average to release a new and less vulnerable version of a project. In 2020, this was taking 73 days, almost 3 months. And last year, it was less than a month. We might expect that in a year, that's every 2 weeks. This is something where we really need to become aware that if open source accelerates, our integration practices will also inherently have to accelerate, and we want to make sure that we're making the right decisions with the right research when we're doing those. So we learned today that there has been an absolute explosion of open source contribution in the last decade, and that's an incredible thing to see. We've also seen that because of that, a minority of those have introduced malware attacks, and we do expect to see that also exponentially increase. We understand now that to evolve your supply chain, you're going to need vulnerability metrics that allow for optimal decision making in real time around versions. And lastly, in order to make this work, we need to understand that we are all responsible for the maintenance of the open source projects that we rely on. We can evolve best practices for vulnerability, but we have to do it at an ecosystem level. If you'd like to understand a little bit more about how we came to observe MTTU in our data, or some of the other really interesting findings that we have from the open source supply chain, look at our State of the Software Supply Chain report for 2021. This just came out, and these are a few of the really interesting findings that we have. All right, that's it from Sonatype. I hope that you have enjoyed this and enjoy the rest of your Devlympics 2021.